Hi friends, welcome back. Today we are going to solve AtCoder beginner context 212 problem mean difference. If you haven't already subscribed to my channel, please subscribe to my channel now. My channel is dedicated to help people who are preparing for Java J2 interviews and coding interviews. On my channel you will find lots of helpful videos for your interview preparation. There are over 300 different varieties of solved problems which are taken from previously asked coding interview questions by big tech companies like Facebook, Amazon, Microsoft, Google, Yahoo and many other financial companies. So this channel can definitely help you in your Java and coding interview preparation, so please subscribe it. So today we are going to solve the mean difference problem at AtCoder. So let's first take a look at the problem statement. You are given two sequences. A is from A1 to AN consisting of n positive integers, and B is from B1 to Bm consisting of m positive integers. Find minimum difference of an element of A and element of B such that the absolute difference between the two elements should be minimum, right? So this is what the problem statement says. They have given us some examples here. So let's first go to the whiteboard and we will understand what the problem is, and then then we will understand how we are going to solve the problem. So here basically two arrays are given, right, and their size is given. For example, this array size is 4, this another array size is also 4, and these 4 elements are given to us, and what we are required to do is find the one pair here with the minimum difference, right? So here, as you can see, one of the pair here with the minimum difference is this pair, right? Like if I highlight it, like 5 and 3, this pair is the minimum difference, right? The difference is 2, right? So the element, we have to choose one element from A and one element from array B, and then we have to find out the minimum difference between them, right? If we take any other pair like 12 and 9, the difference is 3, which is more than 2, right? So this is what the problem is. We have to find out the minimum difference between these two array pairs, right? One of the pair has minimum difference, so we have to find out that. So how we are going to solve this problem, right? So um, so what we have to do to solve this problem is we have to sort these both arrays basically first, right? So let's sort these arrays. So the array A will look like this, right? After sorting 1, 5, 7 and 12, right? So this is the after sorting, and then we will sort the array B also now. So array B will be 3, 9, 13 and 18, right? 3, 9, 13 and 18. So this sorting we have to do, that is the first step. After we do the sorting, let's go through the logic how we will be solving the problem, right? So what we have to do is we will take two pointers, right? Let's say one I pointer will be there. Let's say I pointer will point here, and another pointer will be J pointer, right? So J pointer will point here. Both will point to the first element, right, in the beginning, and we will keep track of the maximum, like the minimum difference that we have seen, right? Minimum difference. So we will compare these two elements and we will calculate the difference. So 1 and 3, the absolute difference is 2, as you can see here. So this is a stat trace I put here for your understanding. So 2 is the difference, right? So we will update our minimum difference to 2 basically, because this is the difference we have seen so far. This is the minimum. So after that is done, in I and J element, whoever is smallest will move, right? Whoever is smallest will move further, which means that I will move further now, right? Because I is 1 and J is 3, so I is smaller, right? So I will move further. Now again we have 5 and 3, again we will calculate the difference. Again difference is 2, as you can see here, right? So we will note down the difference, but difference is not lesser than 2, right? The minimum is still 2, so we will go forward, right? Now again we will have to check who is the minimum. 3 and 5. 3 is minimum, so it means that j will move forward. So now j will move here, right? Again we have 5 and 9. We will compare these two elements. So 4 is the difference, right? As you can see, 4 is the difference, but it's not less than minimum, so we will not update the minimum. Minimum is still 2, so which means that so far we have seen the minimum difference as 2, right? Now again 5 and 9, whoever is minimum will move, right? So now minimum is 5, so minimum I will move basically, right? So I is at 7. 7 and 9 difference is 2, right? So we will still not update our minimum because we have already found the 2 difference, right? So only we will update the minimum difference if we are finding a difference which is less than 2, right? So again we calculate difference, we will move forward. Again now 7 and 9, whoever is smaller will move forward. So I is smaller, right? 7 is smaller than 9, so now I will move forward to 12. So now 12 and 9 difference is 3. We'll note down the difference. Whoever is smaller will move. So now the smaller is j, right? Because 12 is bigger than 9, so j will move. So now the difference is between 12 and 13, right? So difference is 1, as you are seeing here, 1, right? So it is smaller than minimum, so now we will update our minimum to 1 because 1 is the minimum difference we have seen. Now between 12 and 13, whoever is smaller will move, right? So now we already at the end basically, right? This is the end element, so we don't have a space to move. So this is kind of we are ending here, right? So we don't have to now keep checking. And why we are not checking 12 with 18? Because the difference we already checked with the lesser element here, right? 12 and 13 we already checked the difference 1. So the 12 and 18 difference, there is no point in checking because this difference will be more, right? 12 and 18 difference is 6, which is already more than 1. So that's why we will return 1 as our answer at the end, which is the minimum, right? So this is the logic we are going to use to solve the problem. And why this logic works is because whenever we are like taking we have a sorted array, right? And we will be going with this, for example 1 and 3. So basically when we have 3 and 1, right, then 3 can have the minimum difference between this pair or this pair only, right? It cannot have with these other pairs, right? The minimum difference you will find with only a pair which is lesser than or greater than, but which is the next greater than pair, right? So for example 3 is between like this, right? The 3 position is between here, between 1 and 5, so it can have a minimum difference with this or minimum difference with this basically, right? So that's why this logic works. So this is the way we are going to solve the problem, minimum difference on AtCoder. So there is another example, I have it here. This is just I created for your understanding. So here also we will just do the same thing. We have two arrays given, so we will just sort them out first. So first array will look like 10, 50, 70 and 100, right? 70 and 100. So this is after sorting. And the second array will look like 25, 80, 130. Yeah, let me just write down here. So it is 25, then 80, then 130, sorry, 130, and then 150, right? 150 will be at the end. So this is the first, we will sort this array like this. After that we will take the first, this one is the I, right? This is I, and this j will point here, right? So j is pointing here. So we'll calculate the difference. As you can see here, 15 is the difference. Whoever is smaller will move. So I is smaller, right? 10 and 25, I is smaller, which is 10. So I will move here. Now again we'll calculate the difference. Difference is 25, right? So here we will keep track of what minimum we have seen, right? So minimum we have seen so far is 15, right? So 15 is the minimum. Now again 25, again whoever is smaller will move, so j will move here, j is smaller. So now 15 and 80, 30 is the difference. We are not updating minimum because 30 is more than 15. Again the smaller will move, so smaller is now will move here, right? So I is at 70 and j is at 80, so difference is 10. So 10 is smaller than 15, so we'll modify our minimum to 10, right, because it's smaller than 15. Again the smaller will move, so now I will be at 100, right, I will be at 100 and j is at 80, so the difference is 20. So we will not update minimum because minimum is already smaller than 20. So now again j will move because j is smaller, so now the difference between 100 and 130 is 30. So we will not update our minimum because minimum is already smaller than 30, right? So at this point we will stop because we already have seen one pair, this pair, where we have found a difference 30. So there is no point of moving it to 150, right, because we are going to get more difference only, so than 30, right? If we move it here, then 100 and 150 difference will be 50, which is more than 30, right? So we are at the end, we will return 10 as our answer. This is the minimum difference we have seen. So this is the logic. So let's just go ahead and take a look at the Java solution here. So n and m is the size, n is size of a matrix, a array, and m is size of b array. So this is given to us. This is our first example that we saw here. So first thing is we are going to solve both a and b arrays. After that we will take I and j pointers, both are pointing to 0 at the end, and we'll take current is equal to 0, and the minimum difference we will keep answer variable to keep track of the minimum difference we have seen so far. After that we have this while loop, and while loop is I is less than n and j is less than m, right, because n is size of array a and m is size of array b, right? So until we reach end of any array, we will keep calculating the difference between the current I and jth element here, right, the absolute difference. And if absolute difference is smaller than our answer, we will keep updating the answer here, right? And if I is smaller than the ith element of a is smaller than jth element of b, then we will increment I value, otherwise we will increment j value, right, as I shown you here, right, how we increment I value and how we increment j value here, right? So whoever is smaller will move basically, correct? So that's what it means. So we'll do this in while loop. So we'll process the complete array, and at the end we will get our answer is the minimum difference, right? So let's go ahead and execute this code here. So once we execute, it is giving us 1. So 1 is the correct answer. As you can see, this is we have seen here. So 1 is the correct answer here. So let us take this another example also. So let me just take this another example that we saw. So I'll just update our arrays here. So this is our another example, right, where this is the example now we are looking. So we should get 10 as our answer. So let's go ahead and let's execute this example. So as you can see here, we are getting 10, which is the correct answer, right? So this is the logic to solve the min difference problem on AtCoder beginner context 212. So we use the sorting logic of the array. So we first solve both the arrays, and then we use the two pointers I and j to keep counting the minimum difference between two pairs, right? So if you are new to my channel, there is a playlist called as AtCoder. You will find some AtCoder problems solved and explained using whiteboarding sessions there. There are 3 other playlists. If you are looking for solved coding problems, explained coding problems, the name of the playlist is Code Forces, CodeChef, and Leetcode and Leetcode Solutions. So you can go through this playlist. It has over 300 different varieties of solved coding interview questions which are previously asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and any like many other financial companies. Those problems are solved and explained with whiteboarding sessions for your easier understanding. So you can go through those videos and learn different varieties of problems such as BFS, DFS, matrix problems, graph problems, binary search tree problems, coding questions related to linked list strings, optimization problems using priority queues, and a lot of logical questions that can be solved with different data structures such as set, map, queues, stacks. So all these problems are solved using Java, and the links of the solutions is also given, the GitHub account link where you will find lots of Java solutions for these problems. So if you like this content, if this content and video help you in understanding this problem, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. They can also see these solved coding problems videos and understand how to approach different varieties of Java problems, and how to use Java data structures, APIs and libraries to solve different varieties of coding problems. The main goal of the channel is to help as many people as possible in their Java J2 interviews and in their coding interviews, by demonstrating different problems for the easier understanding. So if you like this content, and if this content helped you, then please give it a like. Also, if you have any questions, put your questions below the description section, where you will find the problem link and the solution link as well. Also share this video with your friends and colleagues who can also benefit from this video if they are preparing for any Java J2 interviews. And thanks for watching this video.